Welcome back, dear students. Let us have third part of the lesson today. We have computational methodology of t-statistic from the sampling distribution. Test for significance for a single mean is discussed here. T-test is used for hypothesis testing for one sample mean when the population standard deviation is unknown and the sample size is small. The distribution used in t-distribution with certain degrees of freedom, a sample size should be less than 30. T-statistic usually defined as x bar minus mu by capital S, small s by root n, where x bar is the sample mean, mu is the population mean, small s is the sample standard deviation and n is the sample size. Let us understand one sample t-test with the help of a small example. Here it is a tourist agency, it is claiming that the average number of vacation days per person to be more than or equal to 5 days. They have a sample of 16 tourist data revealed that the average number of vacation days equal to 9 days and the standard deviation is equal to 3. And now based on that information, let us verify the claim of the agency at 5% level of significance. So, solve this problem, we have to understand the sample mean is 9, sample standard deviation is 3, sample size is 16 and degrees of freedom is 15 n minus 1. Null hypothesis is the population mean equal to 5. Alternative hypothesis is that population mean is mu more than or equal to 5. What it means? In null hypothesis, we are making a judgment hypothesis. In alternative hypothesis, we considered the hypothesis of the claim of the business person. Now, coming to the computation of test statistic value, t is calculated, that value become 5.33, p critical value is 0.00042 at 5% level of significance. You can get these values from the standard statistical software packages. Interpretation on this, what you can understand is that p value is very small than the level of significance alpha, which means that we have to reject the null hypothesis and accept the alternative hypothesis. What it concludes? The conclusion says like this: H1 is accepted in the sense that the research claims is that the number of vacation days more than or equal to 5 claimed by the agency is accepted. Let us discuss the next example with the sample data for testing the significance of difference between two population means. Here is the data where there are two sample groups with size 21 and 14. Their sample means are 16.5 and 12.2 respectively. Their sample standard deviations are 2.1 and 2.6. Under this context, we have to verify whether there is any significant difference between these two population means. Now, coming to the pooled estimated standard error, the solution says like this. This is the formula for pooled standard error, which can be calculated and in which the different values that S1 square and S2 square are variances of group 1 and 2, N1 and N2 are the sample sizes of group 1 and 2, and the hypothesis for verification is the population means of the both the groups are same, and the test statistic for significance testing is x1 bar minus x2 bar by S of pooled standard error. So, we have to make use of the calculations for this step 1. The pooled values standard error is 0.797. After that, we have calculated the test statistic. The test statistic formula says that the final value is 5.395. So, we have to make next step of comparison. There is a degrees of freedom n minus k. Here the degrees of freedom equal to total number of groups are 1 and 2, 35 degrees are the total number of observations, k is number of groups, then you can subtract that one, the degrees of freedom will be 33, which is 35 minus 2. And go to the tabled values of the T distribution. The T distribution is having table distribution, and the 5.395 it is resembled as calculated T statistic, which was in the previous slide. When compared to critical values to observed value, the observed statistic value, it is also called test statistic value, is 5.39, and test critical value at the 33 degrees of freedom at 5% level of significance is 2.35. It is observed that the test statistic is more than the test critical value, 5.39 is more than 2.035, which all leads to the test statistic as it is exceeds the test critical value, H naught is rejected. So, interpretation on null hypothesis is that we have to reject the null hypothesis when there are two groups of two population means, and it is observed that null hypothesis is rejected means there is significant difference between the means of two populations at 5% level of significance. This is how what you can test the significance difference between two population means with varying sample sizes. Coming to the another example of comparing the two population means when there is a paired observations. That means, when the data is of this nature, let us consider the data of 8 students, their scores in an examination before and after a program that is being trained. So, this course, after understanding this data, we have to check whether there is any significant difference between the two averages before training and after training. For this, we can also assume that the training impact, if it is there, after training the average should be more. Now, coming to the solution of this, null hypothesis says that there is no significant difference in the scores, whereas alternative hypothesis says that there is a significant difference between the average scores. However, the average score of after getting the training will be more than the before getting the training. So, it can be considered as a one-tailed test. So, H naught such that mu difference equal to 0. Usually, this mu d stands for difference between before and after program. So, when mu d is more than 0, then after minus before will be considered as more than 0, which always says that average score after training program is more than the average score of before training program. So, the difference, if you calculate the column, what it says that this is the difference between the previous score, the current score after program, and the previous score means before program. This is all you can calculate the difference. Now, we have to calculate the values of summation of d and summation of d square. It is something like totals of d and d square. Coming to the formula, this says that the single samples, it is formula is x bar minus mu, whereas it is paired cases d bar minus mu d and s d. In null hypothesis, we are assuming that mu d is 0. So, therefore, on simplification the test statistics should be d bar by s d bar only. So, it is observed that in these values mean of d is equivalent to 22.5, standard deviation of d equivalent to 23.45, standard error of d is 8.29. So, after substituting these values, t statistic, if you observe, that is formula d bar minus mu d by s d bar, where this mu d equal to 0 as per null hypothesis. So, therefore, if you consider the final formula, t statistics will be d bar by s d bar only. Substituting that values, the t statistic value is 2.714, and coming to the degrees of freedom, that is equal to 7, because 8 observations, n minus 1 equal to 7. So, t critical value is 1.895, which can be observed or obtained from the standard t distribution tables or statistical tables of t distribution. You can get the t critical value, it is 1.895. Now, you have to compare the test statistic value is 2.714, test critical value is 1.895. It is observed that test statistic value is more than the test critical value, which means that H naught is rejected. So, finally, what do you mean that there is a difference, there is no difference before and after training, that hypothesis is rejected. What it means that this is accepting the alternative hypothesis stating that the average score after training is more than the average score of before training is accepted. Students, we have discussed 3 examples in a part 3. Hope these part 3 examples have much clarity on understanding the applications of students' t distribution in testing the hypothesis. Dear students, hope you can understand the notion of students' t distribution through its applications. This is a very important tool you can make use of in your future research endeavors. It will be helpful to you a lot. So, wish you all the best. Thank you.